Okay, so 1404, quantiles. Now, we've done mode last period, which was the maximum point. Today, we're doing median. Okay, so median is something to do with the middle, isn't it? So a continuous probability distribution, the median is the value of x. So it's x value we are looking for that splits the distribution into halves. Okay, and because the PDF has an area of 1, the area on each side of the median is half. Okay, but not necessarily exactly, the visually half, because, the sum of them is curve sketching. It's not going to look like exactly symmetrical. Okay, so we are going to use integration, obviously, and also it's pretty much the same as what we did with the CDF, the general formula, but this time we know it's going to be 0.5 for median. This is what we are looking for, okay, that x value, okay. All right, let's have a look at the example. Find the median of the continuous probability distribution defined as f of x equals x squared over 21 in the domain 1 to 4 inclusive. Okay. Now, what we need, first thing is we need to find CDF. Okay, so, and then use the condition we have, and then we go and solve the question. Okay, so first, general formula. We can't do anything, like, common knowledge. You can't do anything until we have some sort of formula to go on with. x1, x squared over 21. Now, remember, the limits, we are not going to put 1 to 4, because if we do that, you're going to get 1. So a general formula, we just do the starting limit to the x. dx equals, now I'm going to take the constant out, x1. So we just do normal integration. So I'll get 21. I'm just going to keep it because it's not going to make any difference. So what I'm going to do here is x cubed. And then I'll simplify as 21 times 3, 63, x cubed minus 1. Okay, so that's our general formula. Now, that's not the answer. It says find the median. Okay, now we can find the median using the general formula. Okay, okay, so step 2, I'm going to find the median. That was simplified into general formula, and that need to be 0.5. So now we have to find the x value. So x cubed minus 1 equals 0.5 times 63. So to be 31.5 cubed equals 32.5. And therefore, I'm just going to put that in just for your calculation. So therefore, x equals 3.2. Okay, so the median is 3.2. What does that really mean? It means whatever the graph we got, well, this is obviously the parabola, isn't it? Parabola. That's our parabola here. I'm just going to worry about the positive part. If we look at it, I just want to visualize this. So we're going from 1 to 4 here. Okay, and wherever it's up to that 3.2 here, this is this area is 0.5 or 50% of the whole area. That's a 50% of the whole area. Okay, so because it's under the curve area, you can't have exactly visually same size for the 50%, 50%. Okay, so because it's growing curve, isn't it? So the first part will be sort of a smaller and then getting bigger. So when we're looking at, if you want a half of the area, it'll go a little bit more than half of 1 to 4. So it's not going to be x equals 2 will give us the 50% of area. That's why we want to find the x value that gives us the median, the half of the area. Now with quantiles, all these quartiles, deciles, percentiles, they're all quantiles. Okay. Now, why do we need all these? Because we know the answer of the area under the curve. It's 1. So we need to find the parts of the areas, and this is one of them. Okay, quantile is one of the ways to use it. I just sums up a little bit in here. So quantiles are just all quartiles, deciles, percentiles are cut points. That's x value. We just did that in example 1. In here, x value we're going to use as a, because remember it goes from a to the where is x, but this a is also x value, isn't it? Everything has to be in x term, so it's x value, but we say a as a starting limit. Dividing the range of a continuous probability distribution into continuous intervals, which is the limit that we got, with equal probabilities. With the quartiles equally parted in a 25%. Okay, so I'm going to have it in here. Quartiles, it's the 25%, 25%, so equal parts, isn't it? But decile is a 10%. Okay, 10 equal parts of 100%. And of course, percentile is a percent per century, like 100 years. So that's how we remember it. So that's 100. Okay, 100 equal parts of 100%. But we will have to use not percentage. We're going to use decimal form because the total area under the curve is 1. So we're going to use decimals. Okay, example 10. A continuous probability distribution is defined as f of x equals x to the power of 4 all over 11,605 in the domain 4 to 9 inclusive. Okay, and then we want correct to 2 decimal places. Now, let's have a look at this. I've just graphed the f of x on here. Okay, so this is f of x part of it from the domain 4 to 9. We want to find the first quartile. So what does that really mean? Where is this x value that will give us the 25% of total area? Okay, that's what the question is asking us. Now, before we start, what do we have to do? We have to find the general formula, don't we? So I'm going to do general formula here. With starting point is always there. We can't change that. And then go to up to whatever x. So x to the power of 4, 11605 dx. Okay, and then I'm going to take the constant out. And then I'm going to continue with the integration. And then, okay, so what they've done here. So 4 to the power of 5 is 1024. And then we times it, what did I do that for? That was 5. So, and then I times 5 times 11,605, you will get 58025. Okay, so that's our general formula. Okay, so we haven't really answered the question yet. Let's have a look. So we want to know first quartile, 25%. Okay, that's 0.25. Okay, so what we need to do is x to the power of 5 minus 1024, 5802 equals now 0.25. So one thing we got to think about now is that x is not the x, it's the a now. Why? Because we want to know where it's going to go up to. So 0.25 times 58,025, you will get, and then we add the 1,024, you will get 530.25, and then you do the power of 1/5, you will get 6.89. That's your x value right now. So really, that's this one here. All the way up to, from 4 to all the way up to 6.89. Okay, 89. It gives us 25% of the total area, which is the yellow color part, is the total area, which is going to be 1. But the 25% of it is up to 6.89. Okay, so next one is a 38th of percentile. So be careful with that. So percentile, so it's like in 100. So we're going to go with 38%. Okay, that's where it is. So because everything is like 1% all the way to 38%. That's where we are. Okay, so that means 0.38. Remember, we are not going to use percentage, we're going to use decimal. So I'm going to do a to the power of 5th, take away 1,024 all over 58,025 equals 0.38, because it says 38th percentile. Pretty much the same. 1024, because 0.38 times 58,025 gives us 22,049.5. Okay, and then we plus 1,024, it'll give us 23,073.5, and therefore A equals roughly 7.46, because we wanted to have 2 decimal places. Again, goes up to where it's like 7.46 from 4 up to that part will give us 38% of total area. 7th decile, so all the way, so 10%, 10% and 20%, 30%, all the way up to roughly here, say 70% there. Okay, so it's going to be 0.7 because it's a 70%. Okay, and I'm going to use the formula again, general formula. So I'm just going to put that in. 2, 4. Usual calculation. We do that. 40,000. 617.5, and then we plus it, we will get 41,641.5. Therefore A equals, I'm just going to write it down for your calculation, 2 decimal places, you get 8.39. So from 4 to 8.39 all the way up to there, we'll get 70% of the total area. This is not a area, this is an X value. Now, I'm just going to summarize what we've done, because it might be a little bit too much for you, some of you. So we started with a PDF, didn't we? So that's the probability. Okay, so it starts with P. So just is to remember, the main thing for PDF is PDF has an area of 1. Okay, so what it looks like this. So P of brackets big X is less than equal to little x gives you this. And of course, the limit domain goes to A to B. So A, B. Okay, and that's when we get 1. Now we moved on to the CDF, the cumulative distribution function. And it's actually just a general formula. Okay, so F stands for formula. Maybe it's easy to remember, capital F of X. And remember, partial limits under the curve. We are not looking for the whole area. It's the part of the area. So we're going to have a limits of A to X. Now, under that, we've done mode, which is a maximum point of PDF. So MM as a mode as a maximum point. Now, to find the maximum point, we had to do stationary points. Look, the first derivative, f dash x equals 0, to find the actually maximum x value, but that's possible x value. So step 2, we had to check by using the concavity. And that is f of a double dash x, and that has to be less than 0 because the concave down gives us the maximum point. Sometimes you have to substitute because x value there, and then your second derivative has x in it. You have to substitute it and make sure the value comes out is a less than 0, which means negative, and that gives us concave down. Now today what we've done is a median. It's a middle number, so still it's mm. It's a different mm. Mode is a maximum point, median is a middle, okay, so 0.5. But we're not going to find the 0.5, is it? It's a part of it. So we find the CDF, the general formula, and use that CDF and the quantile condition, whatever the, quartile, decile, percentile, whatever the question gives you, change that into decimal form and to find its quantile x value. We are looking for x value that gives you whatever the percentage of that total area. I'll stop now.